Hi guys, today we are discuss about the topic of BCS theory. Why do some materials conduct electricity with zero resistance when cooled? The answer lies in one of the greatest theory of 20th century physics, the BCS theory of superconductivity. In introduction of BCS theory, in superconductivity in the phenomena where materials electrical resistance drops to zero and below a critical temperature. This means electrical current can flow forever without losing energy. A dream come true for engineers and physicists. The BCS theory developed in 1957 by John Bardeen, Leon Cooper, and Robert Schrieffer describes how certain materials can conduct electricity without resistance. This occurs when electrons from pairs known as copper pairs at low temperatures, leading to a collective ground state that allows for superfluidity. Like as the introduction, superconductivity baffled scientists of decades. Classical physics candidates explain how electrons, which normally scatter and lose energy, could flow freely in cold metals. Key contribution of the BCS theory marked a significant breakthrough in concerned matter physics. It introduced the concept of copper pairs, which are pairs of electrons that move through a lattice without scattering, thereby enabling superconductivity. The theory are established a solid foundation for understanding various superconducting materials and has guided further research into high temperature superconductors. Mechanism of superconductivity: normally electrons repel each other due to the negative charge, but in superconductors, as an electron moves through the lattice, it significantly slightly uh, distorts the positively charged ion, attracting another electrons, like as the copper pairs formation. In the BCS theory, pairs form due to attractive interactions between electrons mediated by photons. When two electrons with opposite momenta and spin interact, they can form a bound state, resulting in a paired system. These pairs exhibits a correlated motion, allowing to them the move through the lattice without the resistance, like as the video is shown in the uh, diagram. Energy gap phenomena. One of the key prediction of BCS theory is the energy gap, which arises when copper pairs arise in when copper pairs form. This gap resistance the minimum energy needed to break a pair of electrons apart. The presence of the energy gap is a crucial characteristic of superconductors, resulting in the absence of electrical resistance below the critical temperature. The copper pairs moving through the lattice single quantum wave, and crucially, they don't scatter like individual electrons. That's why there is no resistance. Also, breaking a copper pairs requires energy, creating an energy gap. This gap protects the superconducting state unless disrupted by heat or a magnetic field. Phenon interactions play a crucial role in the formation of copper pairs. In superconductors lattice, where vibrations help facilitate that attractive interaction between electrons. These vibrations create an effective medium for the electrons to interact, enhancing the pairing mechanism that leads to superconductivity. Like as the BCS theory not only explained superconducting in many metals in the laid the foundation of quantum physics in material science, to inspire research into high temperature superconductors, which BCS theory does not fully explain. So next time, the BCS theory provides an essential framework for understanding superconductivity. With its insights into copper pairs, energy gaps, and phonon interactions, it has significantly impacted the field of condensed matter physics and continues to guide research towards discovering new superconducting materials and applications. Thank you, guys. Thank you.